so I'm going to share the link now to the Java team. Oh, everybody's going to be late because he missed the late rail. All right, so guys, please click that link and then let me know if you can join that successfully, and then you can hear my beautiful voice in person and through that window. If you can't hear it through the window, it's a problem. Wait, where did that go? Oh, there it is. I always got to fix my hair when I see it. I always got to fix my hair when I see it. Okay, well, it seems like maybe it works. That's good. So yeah, this should be recorded. It's going to be up on YouTube after the class finishes and stuff like that. So you can come back and see what we did. So from now on, we'll try and do that. I also think what I want to do is create like markers. Wait, like points in time where we discuss different topics, and you can zoom to the video at that point in time. So that's the next thing. I'll try to do that. I'm not sure if that's possible yet, but we'll try. Actually, I think you can make your own app for Google Hangouts. Yeah, it's me for sure. So maybe I can if it doesn't exist, maybe I can add it. That'd be cool. Okay. So today, to begin, let's share my screen. All right. So the first thing we're going to do, just like we're going to do every day, is get a message from Joy over Google+, and then we will talk about a practice problem. So today's practice problem is divisibles. All right, so we're going to write a function that accepts two arrays and returns the numbers from the first array divisible by all the numbers in the second array. So here's an example of a method call. This isn't verbatim because this is kind of pseudocode. But if you call divisible with two arrays, one that's 10, 4, 18, 9, 11, 91, another one that's 2 and 9, then 18 is the only one that meets the criteria. That's divisible by both 2 and 9, right? Okay, and then you just return an array of ones that are divisible by both. Because there's only one, that's an array of length 1 in this case, right? Okay. Kind of okay. Understandable, at least. Okay. I'll give you a hint. For the second array, you can multiply those numbers together. And then just see what is divisible by that number. So for the first array, what is divisible by the multiples of the second array? Okay. All right, I'm gonna stop sharing my screen and I'll write it with you guys. Let me go over it. The cool part about this Hangout too is that while I do this, I'm still sharing my screen, so like you'll see me write stuff that you're not seeing right now. Right? Alrighty.
What's used for an array, not length, but
Size. You mean array list? Yeah.
right by 2 and 9, or 2 and 1, sorry.
2 and 9 is the example. Yeah.
Okay.
Thank you.
No, I don't remember how to create an array. But yes, I do. Yes, I do.
All right. Apparently I'm not showing my screen anymore.
What does it mean? My bug says like contents of collection divisibles are updated but never queried.
What that means is you're not using the contents of that array after you make it.
Oh, it's because of capitals. Sorry.
Oh, okay. Yep. So these practice problems, they're meant to stimulate the part of your brain that is like programmer creativity, right? So it's not like you're supposed to know exactly how to do them before you do them. You kind of learn how to do problems like this as we go along. These kinds of things get simpler as you practice them. So we combine like applicable knowledge of the Java language with this kind of like, on the fly thinking, and then the theory is that you put those things together and you're a well-rounded person who's able to have experience and also have, like some like creativity in programming, because you can follow patterns and like just stick to those patterns, and if something deviates and be kind of lost, or we can give you like some problems that challenge you mentally and make you think creatively, right? So if you practice that, you get better at it, then you'll be able to write better programs when you graduate. So that's the idea. It'll make more sense later, because like later we'll be going into frameworks, and it's like this is how we do it. It's like you need to follow these patterns to work with the framework appropriately, and so you'll be like, it'll be less like creative and more follow these patterns. And so we want to keep fresh the whole creative aspect where you come up with new ways to solve problems. Let's make sure we hit that as well.
I don't know what I did wrong. Like I don't think that mine would work.
Well, you can use the debugger. Have you tried setting a breakpoint in your code and seeing what's going on?
Yeah.
It's pretty convenient. In fact, that's like the best way that you can actually, like the debugger, like using your debugger should be like your go-to if something is weird, right?
Like I know where it's going wrong, but I don't know why.
Okay. Well, we can take a look at it if you want to. Yep. How are you guys feeling about this? Or do you want more time, or do you want to review it? More time. Okay. Let's give it another, let's say 10 minutes, and then we'll review what we've done, okay? I have no idea. I'll hold the spot for Joe.
I know what it is. because I can convert it to integer. Like my int I, so my for loop, I want to convert it to an integer, like it's already a string. So I don't know how to do that. Again. Really?
Yeah.
Okay, cool. I'm like, as well, I'm.
So you wanted us to use those numbers specifically, right?
I don't think it matters.
You could test,
Yeah,
so it could be any numbers.
yeah, but you probably want one that's divisible by 2 and 9. So like I used 18 and 36. And this is sloppy. I know it is. And then I made 2 for loops, but I shouldn't have done that. But I didn't know a better way to do it yet. So. And I just wanted to test it because if I can get this to work, then I can add this to this. This is where the problem is, right? I don't like that guy.
Yeah, that one. So this is.
I have him. 18. Oh, you know what? This is why, because I don't have a. Size. Less than or equal to. Size. This will work. Oh my god. Oh my god. Did it work? No, it didn't. But it ran something. It just didn't run divisibles. And that's because this is a string, not a double, or not a string, not an integer. So add dot to integer, or how do you change it to an integer? To int.
So is that line where it says integer brackets numbers equal to divisibles, is that the declaration of the class?
What if you use those guys on your.
Oh, you know what? Hold on. You're right. I have these here. I don't think I should have this there. So I do integer here.
Yeah.
Let's try that. I'm so excited if I get this. add int, make it an int.
Yeah, but that's just the index. Integer element. So all you're doing is put another field in
Yeah,
there plus
no,
the
no,
number.
I think you're right.
So
Do
you add.
this.
Yeah.
Add
and then-
integer,
No. It would be like, what spot do you want to put it in? So 0 and then the index, then the integer.
okay, so
the
index,
first.
integer.
I don't think we need to call it integer. I think you just pass in a number right now. Yeah, it's good.
Really?
Yeah, so I would do
Alright, let's try that.
19.
2, 3,
Uh-huh.
3, 36, okay,
That's what happens.
great. No, but I wonder if I put int and then integer. Oh wait, or did it say, hold on, was it index?
Index, yeah.
It was.
It's index first.
Is it
That's how I had it.
IDX? What was it? Which one? Ah, okay.
So did you make two array lists? Just think of that much.
So now you're able to get for the I equals 0 to the size. We tested that
Finish.
Started doing some Java FX stuff,
Really?
Yeah.
That's our next unit.
and then what I got. Confusion.
All right, cool. What do you think so far?
It's cool. Now I'm saving my outputs in XML. So I'm just trying some stuff.
Oh, no.
Our curriculum lead for Java, he wrote this IDE called Nightcode for Clojure. He wrote it all in Java. I think it's all open source, so don't you look at it.
Okay.
Like, when you get the URL, you can see kind of what the commands go for Java.
Yeah, I mean, I just did like the to-do list thing that's like in the unit. It's fairly simple. So I tried, over the weekend, I tried to make like a game and it's like, I have no idea what I'm doing. And then that was much simpler. So,
Yeah.
so I think I understand it.
We do have, there's also a lesson in there about libGDX. Is that what you tried to do?
No.
Okay.
I have this game on my tablet at home that I'm like addicted to, and it's like pretty simple. So I'm just trying to like clone it basically.
Okay. What's it called?
It's called Adventure Capitalist. It's like a simulator. It's but it's all like could be text based.
Is it like Mob Wars? Like something?
I don't know.
Do you remember? Like, do you remember TI-83 video games? Like,
No, I don't know what words though.
yeah.
It's basically like Lemonade Hacking or like one of those games
Okay.
where you like build something up and then buy the next expensive thing.
Yeah. Cool.
So conceptually, it's pretty simple.
That's awesome though. Well, yeah. Man, I gotta get more creative with ways to like use the different aspects of the Java language. Because there's lots of stuff that we haven't covered yet. That, we're trying to like gradually get to. There's other things that might be interesting to you that we don't cover the rest of us. Did you like you talked about research interfaces yesterday, right?
Yeah.
Do you understand kind of why interfaces?
Yeah, I think so.
One of the coolest parts about interfaces is that you can like Spring uses them actually for a dependency injection. So dependency injection is like, if you can wire up your fields like the classes load, they'll automatically have values. And in a file somewhere, you're like, whenever you see this type, this type. Like whenever you see this interface, give it this type. So if you ever want to change, so if you program against the interface, like if you consume those field types of interface, then you can swap out the implementation later, and like, as long as they conform to the same interface, then you shouldn't have experience. I Right, so like if I have an interface that's like flyable, this is the interface that I always use as an example, and that's one method called fly. Right? Like, you know, if I map all instances of flyable with like an error class, then that's fine for fly. And then later, if I'm going to switch it out with the airplane, I know for a fact that I haven't ever written anything that's specific to the bird class, just the interface. That's what the interface is going to feel like. So I can swap out that class with the other class on the fly. So it's a way to like modularize your code so that like you can make architectural decisions later.
Okay.
It's pretty legit. It's like definitely what you would see in a like a senior developer. Right. That's pretty awesome.
Okay.
We'll go over it more later, but I thought maybe you did the full IS interfaces.
Yeah.
All right, folks. It's been about that time. So let's talk. Did anyone get Avery? Yeah. Okay. Avery, why don't you share your screen? We can take a look at what you did.
Okay. Let me bring it up.
I got 0. I got it to work, but it didn't pull the numbers.
Yes.
No.
Step 1.
No.
Get 0. Step
Get the number
2.
out.
Right. Okay. Do you know how to zoom in?
Yeah. It's a little.
Just use your trackpad and like pinch to zoom.
Okay, so it's a little cluttered because it's my scratchpad from yesterday.
That's cool.
Okay.
All right. Talk to me. Let's talk through the solutions.
The solution part.
Yeah, it's just everything. Wherever you go. Like, let's include this because it's really awesome.
Okay. All right, so this is just a comment at the beginning to say what this is. It's our morning exercise for today. So this function takes into int arrays the dividends and the divisors, returns the dividends which are divisible by the divisors, which is just math speak for what we're trying to do. And these are the parameters and what it returns. And this is Javadoc format.
Yeah. So if you were to build, there's a command you can run to build a Javadoc over your code, right? And if you have it marked up like this, if you have comments like this specified, you see it like IntelliJ is highlighting this and this for us. Then it'll build that nice web page that we saw before. You know, whenever we go to like the string documentation and the math documentation, it's a nice full website. It will build. If you have stuff like this, then you can have that same thing for your project as well. Anyway,
What's this called? The thing that you pushed?
The comments?
this part,
Yeah, you said something if you push something, what did you call it?
Javadoc. Yeah, so like Javadocs are a special format that you can give comments on your code that are recognized by a tool which will scan your code and then build documentation web pages for you. IntelliJ, you can let's see.
It's just a comment. So if you,
Is that an asterisk? You just have an asterisk or?
yeah, so like if I have a public
Yeah.
void, do something.
Yeah, so there's a under the tools menu you can say generate Javadoc, and it'll add a series of HTML pages to a folder in your hard drive. You open it up and you'll see like all your classes and everything you documented. Pretty cool.
Okay, so I guess we could have returned an array list of integers.
Yeah.
But
That's one option.
I didn't think about that. So anyway, so it's public, it's static, because it doesn't work on the main object. It's just available to the inside the main method.
Yeah.
So we declare an array list of integers called results, and we use an array list instead of an array because we don't know how many matches there will be.
Yep.
And so then the next step is to find the lowest common denominator of the divisors. And the easiest way to do that is to just multiply all the divisors together. So what this does, well, so we initialize it to 1. And then for each number in the divisors array, we just multiply them together. So in the example, it was like 2 and 9. Lowest common denominator would be 18.
Well, I did something totally different.
Does this make sense though?
Yeah, this is prettier.
Much
prettier.
All right. Yeah. Okay.
Okay, so then now that we have lowest common denominator, we want to go through each of the dividends and see if any of them are cleanly divisible by the lowest common denominator. So basically, this is just a for loop that goes through each one of those dividends, and it checks if this particular number is, if the modulus of this number and the lowest common denominator is 0, which means that there's no remainder in direct division, and we add that to the results array list.
Mm-hmm.
And then if we were going to return an array list, we could just return right here. But since I'm returning an integer array, these next steps just basically create an integer array out of an array list.
Yep.
And so there's a function of an array list called toArray that I couldn't figure out how to use. So that's why it's stuff this way.
Yeah.
Can we upload can you upload yours?
Yeah. No, we're gonna upload. I mean, the solution I have is very similar to that, so we'll upload it.
Oh,
Yeah, mine's on my GitHub. There's my Scratchpad.
If you can post that to Iron Java, like the reference to the Scratchpad project,
Okay.
then people can bookmark yours as well.
So you basically like chunked it into 3 parts. The first part was to do the math for the divisor. The second part was a dividend. Well, for the 4 parts, the first part was to declare it, right?
Mhm.
The second part was to declare everything. You have to declare all of the aspects of it, right? And declare everything in line 0 through 2.
Here? Yeah.
Yeah, okay.
So yeah, this is just the array list that's gonna, eventually we're gonna return something based
Okay,
off.
so then the next part, you declare and do the math for the divisor, then the next is the dividend, and then, and then the array list is what you have up there. The array list, integer results in the array list
Mhm.
is the integer size results. That part right here.
Yeah, so these steps are just to take, so we already have our results in an array list, but we want to return an integer array. So everything from here down is just converting the array list into an array, and then we return the array.
what did you do at the top? So where you have public, static, int, visible, and so so you declared that like up there? Or what-
Yeah, this is just the method.
Yeah, so, but you put in like the parameters then would be like int.
Yeah, okay, so then the way you call this, ignore everything right here. So this is just the public static void main. This is just our main method that will get called when we run it. So this is just letting us know what happened. So these are the dividends. These are the divisors.
Oh,
And
okay.
then we store the results and we call divisible. And we pass the integer array dividends, integer array.
Oh, and then you did a for loop for int art result. Okay.
Yeah, so in this case, there's only one result, but if it's sort of bigger data set, there might be 10 results or 5 results. So this will go through each one and print it out online.
All right, Avery, man, well done. Good job, dude. All right, now I've written up 2 solutions. Let's go over the one that's similar to Avery's real quick. By the way, Avery, the only feedback I would have for you is that your naming is divisor and dividend. I just pluralize them, like divisors and dividends. Yeah, right, because I mean, it's an array of things or whatever. But that's really, really trivial compared to, you obviously got it entirely correct. Okay. So, going over the solution. So, we have numbers and divisors. I use the term numbers. Dividends is a very concise way of naming it, probably updated to dividends at the beginning. So int divisor equals 1. So basically I did exactly what Avery did, where you just multiply times the divisors to get the least common denominator. Right? So this is basically the same as the LCD variable he had. Right? So I'm making an array list of valid numbers. Again, it's an array list because we don't know how many valid numbers will match just yet. So for all of the numbers, if that number is divisible by the divisor, then we want to add that number to our valid numbers array list. Okay. And then Avery, here's where you guys screwed up. Valid numbers like 2 array, you pass it a new array. This actually is, you can't type new primitive array element like there. So like, they're just changing the return type to an integer array rather than convert them to an int array. So the reason why this doesn't work is because we're talking about boxing and unboxing variables like types. 2 array expects a type t, and ints are not types, right? So the integer is a type. So if you ever see something that accepts a type t, then it has to be that class. Okay. This is the class name for it. So basically, just converting this array list to an array. Right. So we run it, and we get what we expect, which is 3 numbers. Okay. So exactly how aside do you guys get the overall approach? You generate a lowest common denominator by multiplying all the divisors together, and then you check using a for loop each number against that lowest common denominator. And if they're divisible, then you add it to your list and basically just return that list. So the next thing I want to do is show you another solution. This other solution is kind of where we're headed. This is our end goal. So this is code that will be clear as we progress along the course. I think it's still good to see where we're going. Okay? So maybe this is something you should look at as well. In your free time, if you want to take a look at this as well. So this other solution uses a concept in Java called streams. Now, streams are a very powerful, very powerful language construct. Basically, streams, like if you think of like an input stream like we read before, it's like we have a scanner that reads a stream from like system.in, right? In streams, you can think of them the same way, just a stream of integers, right? So, you see here, I'm building the divisor. So that's my ultimate goal on this line, is to assign this divisor variable. So how I'm doing that is I'm taking my divisors list, and there's a static method on the arrays class that I can use to convert that to a string. Right? So at this point, it's a string. Okay? Once we get here, what we're going to do is perform a reduction. So a reduction is like, it's a mathematical operation where you have a current value, you have the next value, and you want to combine them into one value. So you're taking a bunch of values and you're mapping them all down to one value. All right? The first parameter to reduce is the identity, which is number 1. For multiplication, if you multiply times 1, then you get that number again. That's the identity. And the second parameter is the function to map this number with the next number to convert it into one number. So for each number in our divisors list, we're going to multiply this one times the next one. Okay. So at the end of the day, we'll get 1 times 2 is 2, and then this will pass into 2 and a 9, and then it'll turn 18. So the end result of this is going to be 18. Right?
What did you just point to? The divisor?
Yeah, so the ultimate goal in this is to assign a divisor. Okay. The way we're doing that is by converting our array to a string, and then we're performing a mathematical operation called a reduce, which takes a series of numbers and squishes them down into one using an operation. The operation here is to be multiplication. So starting with 1, we're going to run this function. This function is going to run number 1 and the first element of the function. What we're doing with those numbers is we're multiplying them together. So 1 and 2 is going to output 2. Then it puts 2 with the next value. And it uses that value with the next value in the string. The next value we use is 9, so it's going to return 18. There's no other element in the divisors list, so that's 18 is our thing.
So the 1 is where it starts first?
Yes. Yes. 1 is the first value passed into this first parameter.
That you assign, you decide that it's 1.
Yeah, so like I've specified here that it's 1. Yeah. If I specify 2 here, it would begin I with 2, and we'll multiply 2 times 2 together to give us 4, and then 4 times 9, so it gives us 36, which is twice as much as we need to be. Right? So Matt, reduce is still something that I haven't, it's a very complicated thing. So if you see it and it's like, man, that's crazy, that's the expected response, right? But this is kind of our end goal type code. Okay. So on line 29, we've converted our divisors list, or divisors array rather, into one divisor. We're going to return a filtered list, which is all the things that match, all the things that are evenly divisible by the lowest common denominator, right? So same thing we did before, that for loop, where like, okay, for each number in numbers, add it to our array list if it's evenly divisible by our divisor. We're doing the exact same thing here, except we're doing it using the stream API. So we're going to take our numbers array, we're going to convert it to a string, like before. So it's the same if you call from here and here, right? Then afterwards, we're going to filter this stream. So filter, water filters or air filters, it takes a whole bunch of crap and just only gives you the things that you want, right? So the parameter to filter is a function. This function will iterate over every single value in the stream. So for each value in the number stream, it's going to say, so we're going to call the value I, and if I is equally divisible by the divisor, this is going to return true. And so the filter method will add it to the resultant string. So filter also returns a stream. So arrays.stream numbers will be a stream of all the numbers. After a filter runs, it's going to be a stream with only a small subset of numbers that match the criteria. Then after we filter that down, we'll convert it to an array with all 2 array. Now we're done. It's pretty legit. What's up?
The arrows, so like in the for, like, is that just kind of like this unfolding?
Not exactly, no. It should, in fact, what this defines is what's called a lambda expression. It's a function with no name, okay? So we've defined so far functions with names. Like this function has a name, divisibles, right? Or we have a main function. This is a function that has no name. We're only specifying the behavior of the function. So filter is expecting a function, right? And we're giving it that. And lambda expressions are a syntax in which you can say that. So what this is saying is, filter is expecting a function that takes in an int and returns a Boolean. That's what filter is expecting, okay? So basically we're saying, here's a function, I, it's going to assume the type here. It's going to say I is an int, and since we're doing this Boolean arithmetic, this is what gets operated on each time. This will return a Boolean. This is a function that accepts an input I and returns a Boolean. That satisfies the requirements of the filter method. So filter is there's a for loop in the filter that iterates over every element in the stream, and then for every element in the stream, it's like execute this method. And if this method is true, then keep it as part of our stream. Right? This is the syntax. The dash greater than is the syntax for building a lambda expression, which we'll get into more detail later. But brief introduction to lambda expressions.
Sorry. So where it says public stat int, what exactly are you declaring in that one line?
Here,
Line 26.
in line 26, this is the definition of our method. We're declaring our method signature here. So we're saying divisibles is the name of a method. The access modifier for that is public, so this method is accessible by any class in any package ever, right? It's static, which means that this method belongs not on instances of its containing class, but just the containing class, right? So you can reference it by saying main.divisibles, okay? And then we know that it returns an integer array, and it accepts 2 integer arrays as inputs.
Okay.
Yeah?
Yeah.
So each part of that making this gelling. It's good.
Say that part again, but not divisible again, I'm sorry.
Which one?
You said it returns it integer array, and what was the next line that you mentioned?
It accepts 2 parameters, which are also integer arrays.
Which are the number of classes.
Yes.
And you declared your your arrays up there, so like in nums, divisibles, and that's like that's the set of numbers that will go into, or that will be used as like the divisibles.
Yeah, so I'm just declaring a new int array here as the first parameter. It's going to be passed into divisibles as numbers. And
Okay.
the second array is going to be passed in as divisors. Yeah. And I added a bunch of numbers here just to test multiples of 9.
Can you show the next array?
Yeah, sure. It's just 9 and 2, I believe.
Okay.
So this should mimic the demo. Plus, I added some, again, multiples of 9 to make sure that things work.
And you'll post this?
I'll do it right now, right in front of your face.
So you sorry, you find or you declare those new divisibles? Like what's the proper word? What you did with divisibles new?
I'm defining a new int array object. Okay. When you declare something, it's like a variable. Like you'll declare a variable. So we're not really setting a variable when we pass it into this method. It's just making a new object, defining an object, / instantiating an object, right? However you want to say it. So we're making a new object and we're immediately passing it into divisibles. Okay. So if we want to save this stuff,
Wait, are you making a new object? So the object would be like the numbers?
the object would be an integer array object.
Yeah.
The
Okay.
values of which would be these.
Got it.
Yep. All right, so let's go ahead and add this stuff. I think it's in August. Oh, oops, that's great. I'm glad I have 2 directories to say the same thing. So type, oop. Hmm. Go to GitHub. Jesus Christ. So let's go to GitHub and what? Yeah. Oh, yeah, that's why. I made a repository in the organization. It's down here. Rangeman?
Isn't like a shooting range?
No. Back when I played Counter-Strike competitively, the name I went by was Rain with a Y. And then I decided when I wanted to make an email address that I would just squish my name and that name together. So it's Benjamin and Rain squished. So that's it's never taken by anyone ever else. So it's just taken hold of my life as the thing that I name myself by, because no one else has that name. So, all right. So we have let's see. We have my old scratch pad from the previous cohort. Let's make another one. New repository. August. Actually, you know, I don't want to keep doing that. What's the best way to do this? Let's archive this because I don't even care about it. Settings. Delete. TIO. Oh, let's just copy and paste this. It's deleted. Now I'll make a new one. We'll make a new one in the TLS Charlotte Java repository. We'll call it Scratchpad. And we'll not initialize it to anything. We'll copy this git clone URL. We'll get init here. We'll get promote add origin that. We'll get push dash u origin master. Oh, get add dot get commit m adding Scratchpad things. Get push dash u origin master. Bam. There we go. Copy this, and then we'll add it to the Iron Java. I'm going to pin both of these to the channel so you guys can see all of them. Wait, yeah, here. So yeah, my Scratchpad and Avery's Scratchpad both pinned now. Okay. Sound good?
Where'd you put the link?
In the Iron Java Slack channel, and they're pinned messages, so they should always appear right in front of your face, all up in your face. Okay, so I want to cover a couple things today. Now that we've gone over the practice problem, well, actually, first I want to field any questions you may have about the homework. Is there anything that you guys tried to tackle that was difficult that we need to review, perhaps?
Creating a new object, or creating like a new, like I did a grocery store, so I did like fruit, vegetables, meat, et cetera, et cetera. So I'm on like creating a new fruit, and so that's like I'm kind of
Okay.
creating a new player.
So that that static create object method is what got you confused.
Yeah.
Yeah. Okay. I imagine that's going to cause a lot of confusion among many people, right? Because that's the part that is like really like the hard part about the project. So let's review our static character method here. Okay. So let's look at what this is doing and kind of map out like what is actually going on here. So we have three classes here. We have character, we have player, and we have enemy, right? So if we think of it like a hierarchy, we have character up top, right? Think of it like a family tree, okay? A family tree that's not totally jacked up like 1700s in England where they had sex with like like they're sisters, and like I don't know. It's like a legit tree, right? Not like these weird cycles. So character lives at the top. This character's got 2 kids, player and enemy, right? They're siblings. Okay.
Yes.
So in this terminology, every player that exists is a character. Okay? And every enemy is a character. However, not every player is an enemy, right? Clearly. And not every character is a player, not every character is an enemy, since character is made up of both players and enemies. Right? So if we write a method, like build character in this case, that returns a character, it can return any object that is a valid character. Okay, so instead of having like this conditional here, let's say like, make it less based off the input. In fact, let's just have it return a random character type, okay? So if math.random is greater than 0.5, we're going to return an enemy. If it's less than 0.5, we're going to return Ben. All right? So this method is going to just continually return random sets of objects. Okay? And we're not going to know if they're players or they're enemies, but we will know that they are characters. Okay?
We will know this because they're in the character class.
We will know that they're characters because the return type of build character is character.
And because that's what the enemy is a character.
Enemy is a character and player is a character. Yes. So let's do an example. So let's build 5 random people. So keep in mind that we have this make noise method that we got. Let's make sure it's an override. No, we're on character right now, so it's not override. So we have on character, we have a make noise method, right? Just like we had for animals. So on character, it says I'm a character. For player, make noise is an override that says I'm a player. And for enemy, make noise has an override that says I'm an enemy, I guess, frowning face. Right? So let's go and let's use our build character class to just build a bunch of random crap. Okay? So let's comment out what I have so far. So let's build an array list of characters. Oops, that's not right. Okay. That's how we build a new array list of characters. So let's fill this array list with characters, random ones. Okay. So for int I equals 0, I is less than 50, I plus plus. We're going to characters.add build, was it character? Yeah, character.build character. Remember, we moved all of the parameters from that, so it's just build character, right? And remember, build character is going to give us either an enemy or a player, right?
It's gonna be random now?
Yeah. Yup. Right?
You zoom in.
Oh, sure. Yeah, sorry about that. So we're going to fill our characters array list with random characters. Okay.
Do we know like how many are gonna be enemies and how many are gonna be players?
Nope.
Build up with 50 of them, right?
Yes. Oh, actually. So for each one of the 50, after we've built the array, we'll iterate over it again.
Why?
Remember, Joy, that we're recording this. But if you want to record it with your phone too, feel free. I'm recording it like so that we have like so you don't have to worry about that.
So where do I access it?
I put it in Slack.
Oh.
Yeah. Okay. All right. So for each one of the characters, we're going to get one at the current index. So this will get us the current character, and they're going to call make noise on that character.
So will it automatically build whatever character it wants to?
Just based off of whatever build character returned. So if math.random returned greater than 0.5, then yeah, it'll build an enemy. If it's less than 0.5, it'll return.
Oh, okay. So math random is like what will determine it.
Yeah, it's just totally random at this
Okay.
point. Yeah. And the reason why we can call make noise is because make noise is a method on character. If it didn't exist on characters, if it only existed on enemies and players, we wouldn't be able to make this call because it's not an override for a base class.
Oh, this is cool.
Yeah.
Okay. Yeah.
So
I
what?
wonder how many are going to be enemies.
That is one of the questions. Yeah. So what do you think is going to be the output of this execution right here? Line 35 to 37.
It will either be, it'll be whatever the character is, right?
Yeah. How many lines do you? I mean, are you going to see?
50.
So you're going to see 50 lines to say I'm a
Yeah.
whatever.
I'm a player, I'm an enemy.
Yeah. But we're calling make noise on character, right?
Oh, so
No,
will
no,
it be,
no,
I'm a character?
No. No. You are exactly correct. I want you to dwell on the fact that even though what we returned from build character is a character, when we call that method, it uses the method from the object that was returned and not the base method from character. So let's go ahead and see the execution of this. Boop. Yeah. So they have a bunch of random players and a bunch of random enemies. And note that none of them say I'm a character, right? This is the heart of object-oriented programming. This is a concept called, you might want to write this down. It's called polymorphism. It's the ability to call the same method and have it do different things based off what object.
How do you spell polymorphism? Morphism. Okay, I think I got it.
Yeah, it's kind of how it sounds. It's not like it's like polymorphism.
Yeah.
Like Mighty Morphin Power Rangers and polygons.
So it's all the same method and do what?
You call the same method and it does different things based off of the object type. So from the consumer standpoint, if all I care about is characters making noises, I don't have to worry about how players make noises or how enemies make noises. I'm like, I know that all characters are capable of making a noise. You make your noise, player, and you make your noise, player or enemy, right?
Yeah.
It's like whatever character's returned, you make the noise that's responsible for it. So if we were going to apply this to our homework, if we create a new object of that type, so instead of build character here, so say we pass in a string, the string is the category, here, right? So if category dot equals bad guy and return new enemy, Victor freeze. Do you guys remember that guy? I think his name was Victor. Victor freeze.
It reminds me of, do you ever watch Claymation for like Christmas, the Claymation TV shows, like your specials?
Yeah.
And there was like Mr. Freeze.
Was there Mr. Freeze?
Yeah, and
Like-
he was super cool. Everything he did, like he would like point at things and it would freeze.
Claymation, Mr. Freeze.
Yeah.
The
there you
snow.
go.
Oh, it's Snow Miser. Snow Miser.
Yeah, Snow Miser.
That guy.
Yeah.
That guy's creepy as shit.
Yeah.
All right. All right, we're gonna not do that anymore because I'm freaked out by that guy. All right. So if otherwise, the category that equals good guy, and we're going to return new player. We're gonna call that player Ben, and then we're gonna give him 1,000,000 HPs and 1,000,000 and a lot of hit points or damages. Ben does a lot of damage, right? Otherwise, we'll throw a new exception. This is not a valid person type. All right, character type. Let's make it more quick. So if we throw an exception, we have to be able to handle that exception or throw it ourselves.
So would you do one of these for each one of your categories? So since we have 5 categories, would you do if else 5 times?
You could do that, or you could use a language construct that's designed to pick one of a series of.
So you use
Well,
switch.
if you want to do that, then absolutely, yeah. Switches would be a totally valid use case. Does this all make sense?
Can you leave it up for another second?
No. Yes, I can. Sorry.
God, I love the emotion I forgot about it.
It's good stuff. Very freaky though, claymation.
Yeah. A lot of work.
There's a lot to be said. There's those slasher films like in the 80s, like those B movies that like have these really over the top gory graphics.
Yeah.
And they were not like computer generated. They were like some dude's job was to build a human replica made of like freaking Jello and
Are you serious?
ketchup pack. I don't know what I'm serious that was his job. I have no idea how he did his job. Yeah.
That's crazy. Oh,
Yeah.
what happened to that guy's job?
He lost it, or he learned how to write code.
Yeah.
And that's the parable that we are following. He lost the job, or he learned how to write code is typically what happens to things nowadays.
The New Evil Dead, and using CPI.
No way, really?
Yeah. Like old one.
Nice.
It's actually pretty good too.
Yeah. Well, I mean, it's really. I mean, if you think about it, I mean, your imagination really fills in the gaps of anything. If you've got that suspension of disbelief going on, then you can basically do whatever you want. Like I remember back in the day, like the Ocarina of Time Zelda games being like gorgeous.
Yeah.
And if you look back at it now, it's like literally his hand is like a box. It's like one texture, right? And like his pony Epona is like hardly recognizable as a horse, right? But you thought that it was like this brilliant adventure because your mind took you there, right?
It's weird how things work like that, right? Like
Yeah.
Ghostbusters, I thought it was like so incredible. I mean, it still is incredible.
Yeah. Yeah.
Like,
Yeah.
yeah.
It's good stuff. Also, Christopher Nolan is pretty famous for wanting to use like actual physical props instead of CGI. And it actually adds a lot of realism to his movies, I think. Like that scene in one of the Batmans, I think it's Batman, The Dark Knight Rises. Oh, The Dark Knight. With Bane, right? The scene where near the beginning where Bane is caught in the plane and then the other plane overtakes that plane and like hooks up that plane and like blows off its wings and as a tube, like the plane body is just hanging from the other plane. That legitimately happened. Yeah.
That's
Yeah.
cool.
Yeah.
The scene was crazy.
Yeah. I mean, not the entire scene. Like they use like I mean, I'm sure that all the parts that involve the people were probably not that scene, but I do remember a specific still from the filming of that movie where there was a giant plane tube hanging from another plane.
Wow.
Yeah.
That's so cool to see that too. Like,
Yeah, it's a fun profession. I actually, when I saw The Lord of the Rings, I was like, why would you ever make any other films? I was like, all right, we're done. We're done making movies. That's it. We've reached the pinnacle. We might as well just stop, right?
first time I saw Lord of the Rings, I was like, all right, I'll watch Lord of the Rings. And then I had to watch 2 and 3, like, immediately following.
yeah.
I was like, this is so
Yeah.
good.
Return of the King is great. And I can just imagine what it would be like to be a part of making that movie a reality. It just seems like it'd be so freaking incredible. And if you write code and you like movies, then you can write code for movies. Some of my friends do. They work for Pixar and DreamWorks. So,
Oh, cool.
yeah.
A friend that works for Pixar.
Every Pixar movie
He's
is
the art director there.
Nice.
Yeah.
Yeah, actually, we had this. I had this virtual reality class in school, and my other 2 colleagues went to go work for Industrial Light and Magic and DreamWorks. And in 101, actually, I had a TA who, his name was Nathan Cornea. He was freaking just brilliant. He got his PhD in the middle of the class, and I remember seeing the Incredible Hulk and seeing his name in the credits of the Incredible Hulk. I was like, I know that guy, kind of. He would vaguely recognize me. But yeah, I mean, programming is a huge part of the whole, like every single movie and TV show that exists nowadays. It uses a lot of programming, so that gets really interesting really fast. So yeah, we'll talk about it later. But for now, let's focus on polymorphism. All right, so we're all set with this. Can we kind of see how this might apply to our homework?
Mhm.
Yeah? Does the concept of polymorphism at least kind of make sense to you now?
Can you finish your sentence though? So I wrote down, call the same method and it does different things based on ...
The objects.
The object.
Yeah. So like, this is a major tenet of object-oriented programming, is that you allow these objects to define their behavior and you don't care what that behavior is, right? So basically on character, we're like, we want characters to be able to do this, okay? And it says, it's make a noise. For person and enemy, or player rather, an enemy, is it player or person? It's player. For player and enemy, you're like, I know I have this make noise method. I want to do something particular to myself, right? With this method. And then when you have this build character method, it will return any character. So at this point, you don't care whether it's an enemy or a player. And that's a very important concept, is you don't care about it. Like, you shouldn't care about it at this point in time. If your only goal is to make a noise on that character, you don't need to know whether or not that character is an enemy or it's a player. You just know it's a character that's capable of making noises. You make the noise. So whatever happens is up to the object that was returned. And in some cases, that's a player. In other cases, it's an enemy, right? Okay.
It's applicable in real life too sometimes.
Yeah. Well, you can think of a lot of things, and like, in fact, it might be an interesting exercise for you to try and like look at your everyday surroundings and try to categorize them in ways you might think of in like a class structure.
Yeah.
Yeah.
I've been doing that in my sleep too. Like
Yes.
my dreams do that.
Yeah. Back when I had my middle child, Remy, I was so sleep deprived that I started hallucinating. I wasn't hallucinating like real life. I was like flittering between awake and asleep. And I remember thinking that I could like add functionality to my baby with code.
Yeah, yeah. I like had a dream last night, like new person, like equals new person.
Yes.
Weird.
This is a very strange thing. Actually, if you play Tetris too much, and which I have done and have experienced firsthand, there's a common effect where you will see the shapes in your mind. Like it's almost like a disease. Like they're constantly in your mind. You're like, your brain just makes them and puts them down like that.
I mean, it was cool. Like, it was a cool dream.
Yeah, no, it's not. Yeah, it sounds like a fun dream. Nice. Code dreams. That's great. I do want to say I have one other thing I want to say about object-oriented programming, and it's this. I think I've mentioned this before. I know in particular I had a conversation with Joy about this. The justification for object-oriented programming is this. It's like, imagine you have a car, right? And so there is a functionality in the car somewhere where it's like, basically there's a mechanism that pumps oil throughout your engine, and it makes sure your engine doesn't break, right? And if it doesn't happen, then your engine will destroy itself and you'll have to buy a new car, right? So imagine if instead of that being handled under the scenes, there was a button that you could push that performed that responsibility, right? So every time you were going down the highway, every 2 miles, you had to push that button, otherwise your car would blow up, right? That seems pretty tedious,
Yeah.
right? There would be no cars. Or there would be like devices that plug into the AC unit that like just push that button like over and over again. So you can see like that's the whole concept, is there's an interface the car has with you as the user. You want to be able to steer, and you want to be able to go faster, and you want to be able to go slower. You want to be able to brake. Clearly you want to stop on the highway. And you want to do other things like turn on your lights, right? But then the process by which those things have to get that job done should not be visible to you as the consumer. Like as the driver, I don't want to know how you cycle oil through the car. You need to cycle oil through the car.
Yeah.
And in class architecture and programming, like that difference between me knowing the mechanism by which I cycle oil through the car is that method being public or that method being private, right? So that's the justification for architecting your classes using access modifiers. There's things that happen privately that are encapsulated, and this is the term, encapsulation. They're encapsulated in the containing class that you, as the consumer of said class, are designed to not know about. And then the things that that class has told you it can do are its interface to you as the consumer. It's like, here, you can push the gas pedal, you can push the brake pedal, you can steer the steering wheel a certain degree left or right, right? Those are the things the car is allowing you to do. It's not allowing you to physically turn the tires. It's not allowing you to physically like put gas in the spark plug place and cause things to blow up. I'm not a mechanic, so I can't tell you the exact details of how this car behaves. I just know there's a lot going on there that I don't give a crap about.
Yeah.
Right? I want to get a job done. And the car is giving me an interface in which to do my job that is relevant to me, and that's all I care about.
Yeah. It's
Right.
like there's people, and I've been this person too, talking about programming, but it's like people who talk to you about their job like in great detail and who really don't care about their job. And you're like, I don't care if they're so excited that they tell you like everything, and you're like, I really don't care. And I've done that. Well, like, but yeah, it's like that. Like, okay, good. Good for you. I'm glad you have that. Like,
Yeah. Yeah.
Programming, like I start telling them, they're like,
Stuff.
they're like, I don't speak your language. Like,
I didn't mean for that main message to be like, you don't care about other people's things. What I meant was, if you're using something, that something has been designed for you to use it, and how it accomplishes the goal that you set it on. It may use lots of other things you never know about, right? You shouldn't know about it. Because if you try to learn about it and it's designed to do that job for you, then you might you shoot yourself in the foot 90% of the time.
yeah, I was just kidding. I care about that.
Yeah, it's like people like talk and I'm like, I don't care about you.
No, I didn't mean it like that. I didn't mean it like that.
No, I know. Yeah, I know. Okay. So that's a review of what we need to do for the homework. Also review of what we need to do for object-oriented programming to understand it better, and kind of my spiel on object-oriented programming in general. That being said, are there any other questions before we move on to today's topic?
Anyone in the bathroom?
No. Yes, you absolutely can. Yeah, I gotta stop saying that. Yes, you may go to the bathroom. Also, you don't have to ask me.
All right, I just want.
Yeah, it's cool. I'll just wait. I'll wait. In fact, it's a good time to get coffee that I brewed, and then everybody drank it. I brewed a busy one.
Well, whoever did it last didn't put any coffee in. Just hot water.
Yeah.
That was me.
Yeah, it was like
So I
water,
just went in.
basically, should be.
Oh yeah, because I'm a genius. So so I clearly didn't put coffee in there. So actually, no, there was coffee. You must have made a mistake.
It was like brownish water.
That is weird. Yeah, that's all right.
Suzanne's on.
Yeah, it's not we got other people coming in. We're thinking about getting a interim campus operations manager. All over there. So, you catch it?
Yeah, it's cool. So I've done my mixed version of C++. Yeah. Syntax is yeah. So like when I saw it, I didn't recognize it as Linux.
Oh, really?
I don't know what it was.
In the JavaScript, Java world, that's also C sharp.
Okay. Yeah, I don't know. Well, Linux versions are new to like Java 8.
Those are using that. I remember writing C++ in college. I had a data structures class that was focused on C++. There were templates. Like, I remember not being like if I was not doing C++, just like a few seconds to compile a very simple C++ file. And then it would give me like this really highly verbose error message that was like not even normal related to when I was detecting broken. And then
A lot of these C++ newer stuff, it's like,
yeah.
maybe like 20 pages out, but and sit through if you find like 20.
Right, like let's go to the top of this.
Yeah.
It's relevant, and maybe we'll find our error.
Yeah.
But yeah, it's like when I started writing templates, there was no one to give me clear direction on like exactly how a template should be written. Like you have to define the method signature like in the header file, and I think also in the base, like in the class, you have to define for every type that your class could accept, you have to have another method signature. Or whatever, and I don't know. It was. I
It's
remember.
a ton of work and maybe not that useful. Like it can be useful, but for most cases,
Yeah,
you don't really need it.
which is lame because actually generics are freaking awesome.
Yeah.
Like we've used generics in this class, and I've been thinking about it. And also, I mean, I just use Lambda expression, and I haven't thought about. I mean, I know how it works, and we'll get to how it works later. But you don't have to know how it works.
Yeah.
Just can use it.
Yeah, no, I was for a long time very pro C++, and I'm already pro Java now.
Oh, really?
It's so easy, yeah.
That's a good sign, right? I mean, it's not to say that C++ doesn't have valid problems that it's the perfect tool for,
Yeah.
but it's not.
No, but I mean, just like you have an idea and you want to like just get like a rough sketch of it out. It's
Yeah.
so much easier to do in Java than C++.
Right.
Header files and like,
Yeah.
just everything.
Yeah, I mean, time to market,
a lot
man.
Of tasks that would take, you either need like a special library or like, there's so many built-in string functions and just stuff like that in Java that's like so much easier. than
Oh, yeah.
C++.
Actually, program.
Yes.
Like
Plus-
some of the console applications and like reading in text and stuff is so much easier in Java than C++.
Yeah. Yeah. While C not equals EOF or something like that,
Yeah.
and then read in for your string buffer that you had to like make sure that it doesn't have a buffer overflow. Stuff like that. Yeah. It's a big deal. I mean, it's a really valid value proposition. It's like, your time to market is going to be way drastically smaller.
Well, so like if this was a C class, I feel like we would still be on like the first console application. Like how is this?
Yeah.
It's good that you can like see what's really happening under the hood and see, but like most times you don't need to know that.
Yeah.
It's
It's almost the opposite. That's actually like the most simplest Java program you have being public static void main. There's so much that goes into that you just a lot of people have problems with the fact that you are supposed to just gloss over that knowledge to begin with. And I agree with them to some extent, but I do think that Java is much more approachable to learn for a new programmer than C by far. Like, no questions asked. So, all right, dudes and ladies, people. So let's talk about file input and output. So if you'll remember near the beginning of the class, not today's class, but the cohort, we began a Hello World project that contains like scratch work, like stuff that you don't really, it's not really anything except for like a place to write code. If you want to open that up right now, please do so, and you can introduce these methods, but it's not a requirement for you to do this. Just follow along in some way, whatever way you want. So what we're going to do is we're going to add a read-write file class. And in fact, I'll probably do this in front of you because I think it might be useful here to see how you would update a class with another main method, right? Like if we added a class with a main method, we need to tell IntelliJ to use that main method instead of the one we currently have. So in the spirit of learning how to do that, I'll update this real quick. So I'm going into File, Open Recent. It's not recent, apparently. Got too many things. Hello World. I'll open it up in this window. Disconnect our current process. All right. So far, we have our main class and our person class in our Hello World project. This is indicating we need a read-write file class, and it has a public static void main. So we'll go here, we'll add the read-write file class. Read-write file class. All right. So the first thing we see here is file f equals new file, names.txt. The cool part about this, actually, wait, that's not the first thing we have. I forgot, we need to update our main method. So remember the main's method signature is public static void main string brackets args, the string array of arguments that you pass into your Java program, right?
Don't we have a main?
Yeah, we do. We have a main method in our main class. And that's the kind of the reason why I wanted to open up this project, was because if we, instead of using that main, we wanted to switch to this main, we can do so inside IntelliJ. And how we would do that, we could go up in here and specify the current, what's called a run configuration. Right now, the run configuration is set to main. You see that? And this, and I can't make this bigger, so I apologize. But that specifies the main class. It's like, hey, the main class has a main method that you can execute. Okay? And you can go in here and add edit configurations and add a new one here, and then give it a main class of com.theironyard.charlotte.readwrite file. Right? You can do all that. But instead, you can also just click this green arrow. It's like run read-write file.main, and it's going to go ahead and run it for you. And then in doing so, it builds another run configuration automatically.
Cool.
And you can switch between main and read-write file as you wish. So if you want to run the other one, you just click that. Right? The difference between these two is that in one case you're calling Java main, in the other case you're calling Java read write file. Right? The Java runtime will try and pick up the main class in whatever class you try to execute, or the main method in whatever class you try to execute. All right, so the first thing we have here is a file variable that we're declaring. This is a local variable. We're naming it f. We're setting it equal to a new file object, and we're passing a string that's called names.txt. So if you had to guess at what this is, or what this represents, rather, it's pretty clear, right? This is a file. The file name is names.txt, right? This is an example of like self-documenting code, right? That's a concept that, you know, is pretty prevalent. It's like you don't really need a whole bunch of comments to understand what's going on. It just makes sense, right? To me, this is a thing that just makes sense, right? Like it's like you have a file, it has a file name, done, okay? All right, so the next line is file writer. Again, kind of makes sense. So I see the little head twitch, you see a red squiggly line. I see that red squiggly line also. It says unhandled exception, Java IO exception, okay? IO in programming terms stands for input output, right? Or just in computer terms, not even programming, just computers. That's input output, right? So this represents an IO exception. Now, if you're trying to write to a file that doesn't exist, it's gonna throw an IO exception. Because if you think about it, like there's no way the program can recover from that. I mean, it's a pretty exceptional case where the file exists, or the file doesn't exist you're trying to write to. So you're saying either we can try this and catch it, or we can just say that this throws an IO exception. Which is what we're gonna do. We're gonna specify our main method can throw the IO exception because the code we're calling can throw an IO exception.
So wait, the file, so the IO exception is if the file doesn't exist.
The IO exception will be thrown by the file writer if the file doesn't exist. Or there's some reason why you can't write to the file. Like if there was not enough space on the disk that you're trying to write to, it'll throw an IO exception.
So what would that exception be? Like it'll still allow it?
It's not going to allow it.
Okay.
Like if it throws this exception, like you will not be able to build a valid file writer object.
Okay.
And then you'll have to handle that lack of creation in one way or another.
Okay.
Yeah. So the constructor for the file writer takes in a file f. We're making a new file writer object. Its responsibility will be writing to files, and the file that we were writing to is f. Again, self-documenting, not like super convoluted, right? So before we were storing Alice, Bob, and Charlie, or we were displaying and doing things to Alice, Bob, and Charlie, I think we were looking at arrays, if I remember correctly. In this case, we're doing a little bit different stuff. We have FileWriter.write and FileWriter.append. Okay, so if we think about write and append in English just means adding a thing to the end of a thing, right? So the first call we have is f.write, and we have Alice. The thing to note about fw.write, let's just take a look at the documentation. It says write a portion of a string. Actually, this is not the one that I want to see. It's here. It says writes a string. So this write method takes in a string, returns nothing, and throws an IO exception if it goes wrong. So this throws IO exception if an IO error occurs, and it just writes a string to the file. So that's going to call this other method that writes a portion of a string to a file. It just writes all those portions of strings to the file. I kind of want to see where it's actually throwing the IO exception. Oh, this is an abstract method on writer. Go to implementations. File writer. Oh yeah, file writer. Anyway, it's getting a little advanced. Here over there. Back out. The first method that we're going to call is write. This will write Alice to names.txt. If we call f.w write again, it's going to overwrite alice.txt and replace it basically in essence with Ben. Okay? So if we want to add things to the file, we're going to write things and add them to the file, we have to call a different method called append. Okay? Ow, many typos this morning. Okay, and then at the end we close our file writer. So when we open up a file writer, we're basically using the file as a resource. Okay, the file is a resource that's available to us that we're essentially locking for writing for our own specific uses. If someone else were to try and write to that file simultaneously, this OS would send them an error. Right? It would say you can't do that because it's already being edited by another program. Right?
And if somebody else was, then it would send an error to us.
Yes, so that's another instance in which case the instantiation of a file writer would throw an exception,
Okay.
the IO exception. Yeah. So here we go. If we add to this next line, so scanner equals new scanner. So that should look familiar. It's the same exact scanner object that we're using, or that we use to read input. We're using to read from our file.
I think it's my favorite thing in Java so far. Scanner.
You like the scanner?
Yeah, I do.
That's good, because it's freaking all over the place. So it's a nice thing to like. All right, so check it out. We have this while loop. It's pretty convenient. While scanner.has next, scanner.next line. Well, if we look at has next, it says bloop. Returns true if this scanner has another token in its input. This method may block while waiting for input to scan. The scanner does not advance passing the input. So basically, if you have a file that has 3 lines of text in it, has next will return true while you have yet to scan those lines. So think of it like a cursor, right? Like a mouse cursor. Like if you click on it, it's at the very top left position of the file. If you have the down arrow, it's scanned that first. You can think of it as scanning the first line, right? So that's the same way a scanner works. So we hit next line, it's going to scan that first line of input, and the cursor is going to be on the second line. And if there's 3 lines of text in that file, there's going to be a next token. So has next is going to return true. So if you read the next line, the cursor is going to be at the beginning of the 3rd line. And then if you say has next again, it's going to be true again because there's a token on the 3rd line. You read that token with next line, and then it's at the end of your file. And then has next will return false because it has no next token, so this while loop will drop through, right? So while there's a next line of input to read from the file, we're going to scanner.next line. And we're going to print it. Okay. Now, if we want to reset the scanner to the very top left position, the easiest way is just to build a new scanner object based off the file again. So that is a new object that loses all of its sense of context, right, Istra?
When do we have to build a new scanner?
When you want to read from anything, like read text from anything. Like if you're gonna read text from a file or read text from standard in.
But I mean, like, you have to create a new scanner every time you want to read new information. So one scanner is enough for one method.
Yes, unless the event in which you would need to make a new scanner is if you wanted to pass over that file again, for instance. So if you think of it like a cursor, like in a mouse cursor, like if I'm clicked on the top of the page, so I'm at the very top left-hand corner of this file, right? So say that I have a scanner open on this .java file. Next line would scan the first line and return that, right? And then has next would return true. So we say next line, has next would return true, we'll scan it, next line, next line, next line. We'll do it line by line. It'll return us each line, okay? So at this point in time, if I called it, what, like 9 times, the scanner is gonna be on line 10. So scanner.nextLine is gonna give us the contents of line 10. Now say we wanna go back and say, wait a sec, we wanna see what was on line 4. We can't, the easiest way to go back in time is just to make a new scanner object. And that scanner object, by default, like it did the first time we used it, starts in the upper left-hand corner of your screen.
Can you do like scanner new scanner 4, like in the parentheses, put 4 so it goes to line 4?
Let's check. So let's see if scanner has a constructor that takes in an integer. So we'll try int. No. Integer. Nope. Yeah, scanner has no constructor which takes an int.
So you can't.
Correct. The reason why I said no like that was because that could have happened. See, I've never passed an integer to a scanner, so I can't tell you definitively if it can accept an integer. So to answer your question, I opened up the scanner object, or the scanner class rather, and I looked at this constructors to see if I could find anything that was like 3 the number of lines, right?
That'd be cool if they added that though.
Yeah, I mean you could make your own class that extends scanner that adds that constructor. It might be a neat exercise for you to do.
Yeah.
So it just basically calls next line that many times, right?
I don't know that I can do that, but I'll try. I can try.
You can, yeah. All right. So Joy, did you get your answer sufficiently? Okay. All right. So another method on scanner is use delimiter. So far we've used this next line method pretty extensively, right, to read in a line of input. However, scanner also has a next method. So the next method will return us the next token in our stream, okay? Now tokens in file parsing language, or I guess string parsing language, stands for basically a unit. So like if I have a unit of text, it's usually considered a token. For instance, if I hit next, words in the English language are delineated by spaces, right? So the delimiter for the English language is the space, right? The same is true for standard default string parsing, okay? So if I were to have a sentence like, something inspiring from Shakespeare that would make me seem really intelligent.
To be or not to be.
That I wanted to avoid the sappiness of Romeo and Juliet, though. Wait, is that Romeo and Juliet? No, that's Othello
Hamlet.
or Hamlet. I'm dumb. Is it Hamlet?
A rose by any other name would no big smell of sweet or whatever.
That's Romeo and Juliet. Yeah. Because he's holding Yorick's skull, right? Is that when he says to be or not to be? Yeah, that is when he says that. Anyway, so each one of those lines, each one of those words, if you were to scan over that text with a default scanner, and you hit scanner.next, it would return to you the contents of that one word. And the next time you hit next, next word, so on and so forth, until you get to the end of your input, right? If you change how you define what a token is, then the next token you receive changes. So like say you define your token as the letter E, which would be very strange and weird. Then the next token the token you get from a call to next would give you all the contents between the beginning of the cursor location and the E. Okay? So
Is that a Z or a 2?
that's a capital Z.
Okay.
So in this line, we're calling scanner.useDelimiter \\/ Z. Now, \\/ Z is what's called a regular expression, all right? And we'll get into regular expressions very shortly, but not today. But just to see it here, regular expressions, they are for pattern matching, for efficient pattern matching, okay? That's what regular expressions are for. It's a very deep subject. We'll get into it, all right? But for now, just know that we're trying to match a pattern with the call to use delimiter. The pattern that delineates a new token is the end of the file. // Z indicates end of file, right? So on the next line, when we say string content equals scanner.next, since the delineator for the token is the end of the file, and we're at the beginning of the file, the call to next will give us everything between the beginning of the file and the end of the file, which is everything in the file, right? So this is a method for reading everything all at once, right?
That whole thing from scanner to string.
Yeah, so we're making a new scanner. We're updating its delimiter from what its default is, which is, I think, is space, up to a new pattern, which is \\/ Z, which stands for the end of the file. So when we call next, the scanner gives us everything between where it currently is, which by default is the upper left-hand part of this file, and the end of the file.
So we wanted to just word, like, go to the next word, go to the next word. We would just put nothing in the use delimiter.
Yeah, we just wouldn't call that method, right? We'd just leave it alone. But for the sake of this demonstration, what we wanted to do was, I guess, it might have been useful to say this ahead of time, is read the contents of the file. So this section is read entire file. So the first thing we do is set the delimiter to the end of the file, and we read the next token, which is the entire file. All right. So then we do system.out.println contents.
So.
It's okay.
It's gonna read every file, right?
Going to read every file. What do you mean by every file?
The string contents, that's gonna read every single file you have.
It's going to read the file that you specified in the F variable. And the F variable is this new file object called names.txt.
How is that related to compiling? So like it reads it, right?
Okay. Reading a file is essential to the compilation process, right? So in order, like basically the thing we're doing here, the compiler does the exact same thing. And the first step in reading a language is reading in all the tokens as a part of that language. And those tokens come from a file. So the compiler does read these in token by token. So there's a huge extensive process by which those tokens get converted into, like, they have like symbolic meanings. And then there's like it's called a finite state automaton. It's like basically a giant state machine, right? So like if you're in the beginning state and you see like a number, for instance, it's like this could be an int. And if you read in the next token, you expect it to be related to your int. So it's either like a semicolon or a new line character or something like that. And if it's a new line, you go back to the original state, right? It's a huge state machine. Think of like, have you ever seen like a really complicated Rube Goldberg device?
Yes.
It's a lot like that, or like have you seen like a a mechanical adder device where it like adds things together with marbles? I think it's a worthwhile to look at. Marble add mechanical adder. Marble adding machine.
Is stored in these internal lockers. When the locker is set to the left, that represents a 0. When it's rocked to the right, it's a 1. She'll demonstrate that the second one that is set to 0, you're going to add 1. That goes to the state of 1. If the 1 is added to another 1, it must carry to the 2 bit and carry the 1 bit. This is accomplished by the rocker rocking one again and dropping the 1 marble, which now is cleared. By adding another 1 to this, we have a 1 plus a 2 or a 3, and adding another 1 to this will cause it to carry twice onto a 4 as follows.
Oh, cool.
I will demonstrate the adding machine by adding the numbers 5, 6, and 7 and 5. Number 5 is represented by a 4 and 1 combined. So we have this into numbers. Now we have number 6, which is a 4 plus a 2 combined. And now I have 7, which is a 4 plus a 2 plus a 1 combined. The kernel state is now 18. It's much easier to see if we actually hit the resolving work, which also clears it. And 18 is 16 plus 2, and there's yourself. Now we shall add 7 more numbers. We shall add 21. 16 plus 1 plus 1. 6 is 4 plus 2. 13. 8 is 4 plus 1. 12 is 32 plus 8, which is 40. This might be much lower carry-over. For example, if we start with a number that has most of the bit set, in this case 31, which is 1 plus 2 plus 4 plus 8 is 16. Now if you add 1 to that, that carries over to 32, so we get a whole cascading number. So add 1.
That's crazy.
Result is 32. The machine is running fun to watch when a lot of marks all at once. For example, number 31 consists of a lot of bits set all at once. So if we put number 31 here,
So that's basically how computers work, right? In a nutshell, is that inside a tiny little, like, nanometer wide chip that happens billions of times every second, right?
So amazing.
It is mind blowing. If you think about the scale in which we're working with, it's absolutely batshit insane.
It is.
Cool. So yeah, that's a great insight. Is that the compilation process begins step 1, compile your program, or step 1, read in the contents of this file, right? Step 2, do meaningful things. And just like that mechanical adder had different states that it was in, which, you know, either the ball went here or it went there, the compiler has a very complicated series of states just like that. In computer science terms, that's called a finite state automaton.
I won't remember that. Finite state automaton.
Yeah, it's a fancy phrase for just like the state machine. Yeah.
So is it read first and then compiled? Then
The compilation process has many steps.
is
Okay.
it like simultaneous? Or is read exactly the same thing as compile? Like, is that what it's saying?
Well, it's to say if you really want to look at like what the process of compilation is like, I mean, let's look at the inputs and the outputs, right? The inputs of the compilation process are a series of Java files, and the outputs are a series of .class files. So at some point we have to read each one of those files, right?
Okay.
And then at some point we have to analyze the language in those files, determine if that language is correct, and then rewrite that language in the Java bytecode language that computers can read. So we have file reading, we have language parsing based off of what's called a grammar. So like the grammar will decide what is correct and what's not correct based off of the rules of the language. Right.
Okay.
And then if it is correct, it'll, it passes these lexicographical checks, and then it'll write lines to the assembly, which is read by the Java runtime. So you put that in the runtime and you run your program.
Okay, cool.
So yeah, compilation is an umbrella term that encompasses many different aspects. Yeah. Good question. It's interesting to hear what questions students have regarding like the inner workings of stuff. Because last time I had like on day like 2, they asked me how binary worked and like how like number restrictions work. Like why they were like, why does integer only go up to 2 billion? So we had to talk on that, right? So now we're having a talk on compilers, and you never can predict like what people's curiosity is going to be piqued by. So it's always fun to talk about. And if you want to talk about binary, we can totally talk about binary also.
I was like, that sounds really cool. Let's talk.
We're like, oh, wait a second. Yeah, that's awesome. How about we take that offline? Like maybe we can have a discussion about binary. All right, so the last thing we're doing is printing out the contents of our string contents, right? So let's check out, you'll notice that this, well, you might not have noticed because it's so tiny, but over here, this names.txt file was created. We see Alice, Bob, Charlie here. Let's do something, let's delete this file. Deleted. Any Homestar Runner fans in the audience? No? Oh, strong bad emails, remember that? No? Okay. It's a shame. Okay, so the reason why those were all in one line is because we weren't writing any new line characters to our file. So we see this names.txt appeared again because we ran our program again. So it's important to note that IntelliJ executes the Java program in the same location as the root directory of your project, which is why we see names.txt in our current spot, right? So the file writer is writing that file. The path we're using is just the name of this file. By default, it'll execute in its current directory. Its current directory is this execution directory, which is the root of the project. So the file gets created there, right? Okay, another note to make is that this looks like new lines to us as the consumer of this data, but that's only for the sake of human readability. To the computer, this is one long stream of numbers, right? It just happens to be that some numbers correspond to the letter A, some numbers correspond to L, some correspond to a \n character, which we read as a new line. So it breaks up the spaces meaningfully to us as the consumer of the data.
They're all 1s and 0s, right?
Ultimately, yes. Just like that adder.
So Alice wouldn't be saved here because it's replaced with Bob, right?
Well, we changed our method call from write to append. So yes, Alice would be saved as well as Bob and Charlie. Do you want to see where we're doing that?
Yeah.
Okay. So on line 13, we have fw.write Alice. If we had fw.write Bob, what would you expect?
Then Bob would overwrite Alice.
Yeah.
Okay. But because
that's
we put
not
append, it adds to Alice.
One sec. Time out.
So that'll only be Bob and Charlie.
What?
Oh, look at Alice.
Interesting. You know what? Let's try this. Ah, there we go. So slight addendum is that on subsequent runs, like so say you wanted to write your high score to a high scores list, right? If in your code you made a new file writer and then you said FileWriter.write my high score, it's going to overwrite the existing file with your high score. So you see what I did there? It's because I noticed that subsequent calls to write were not overwriting the text like I had said it did, right? So I did a little bit of research, and I came to the conclusion that it's only distinct file writers will write where write does that. So like I made 2 different file writers. So for this file writer, I said fw.write Alice. So this write method will replace the contents of the file with Alice, and then we're closing that file writer. We're making a brand new one, and then we're calling fw.write with Bob, and then we're appending Charlie. We can do fw.write Charlie also. It'll have the exact same effect. So if you had a method,
Wait, even though we haven't closed it, we haven't closed Bob yet?
we don't close Bob, we close the file writer.
Okay.
So like if we run, okay, so imagine we had highscores.txt, and we run a method called add your name to the high scores list. Okay. If that method doesn't use append, if that method creates a new file reference, creates a new file writer, and then uses fw.write instead of fw.append, then if we're only trying to write one line, at one line is going to replace the rest of the file instead of append the contents to the file.
What if on your first file writer you had an append? Would the next write is overwrite all?
Like this? Yes, this would.
Well, if it had like if it had like a write and append or whatever, however many appends, yeah.
What are you trying to do? Like if we do fw.write.
I'm just curious, like if you ran that right now, would Alice be overwritten as well?
Yeah. Actually, I'm not sure if the call to append would work because I'm not sure if that will write to an empty file. So let's check it out. Yeah, it works as intended. So fw.append is like fw.write, but it doesn't replace the current contents of the file. Okay, so that's how you read and you write files.
Cool.
And also how a bunch of other stuff works.
I liked this lesson.
Yeah?
Yeah.
Nice. I'm glad. That's what I like to hear. Okay. Now, what if we have more complicated data that we had to describe? Not just names of people, right? Say we have like our classes. We want to describe our classes information. It can kind of get out of hand pretty quickly. And we can come up with our own way of representing those files, like our own format, our own specific like format that we use, that we know about, that we can consume. But the problem with that is that if we come up with our own format for how we represent that data, then no one else can really consume that. Because they have to not only know, I guess, the data that we're trying to give them, but they also have to know the format in which we gave it to them. So they have to write something that's like, okay, I know it's going to exist in this format. So once I can write the thing that can read things in that format, then I can write the code that actually reads those things, right? But before I know the format, then I can't do anything. Yeah. It's like if you try to read a file that contains an image, like if we, right now, not knowing how to parse images, if we did that same file read thing, we wouldn't know how to convert that to an actual image that we could see because we don't know the format of JPEGs yet, right? So it's very useful to have a unified way to transform data or to transfer data from me to you. So if we use the same structure to describe our data, then you don't have to worry about what structure is that, what format is the data in. One such structure is called JSON. JSON stands for JavaScript Object Notation, and it's a very popular way to transfer data from one place to another. So if you have an object, and you want to convert that object to a string, and then you want to convert that string back into another object, which can be very useful in a variety of ways, right? Like if you wanted to send data from a web server to a web client, for instance, it's one way to do it. Typically, people are going to convert that object into a JSON representation of that object. JSON, JSON, they're the same thing. The creator of JSON calls it JSON. His name is Douglas Crockford, but everyone calls it JSON because it looks like JSON, right? Okay, it's JSON. So JSON is how you can, that process by which you take an object and you convert it to a string is called serialization. And the format is JSON, okay? And the process by which you convert a string to an object, deserialization. Right, so we have serialization, deserialization. Okay. Now this is especially relevant if you want to say store an object in a database. Right?
So an object to a string, sterilization.
Serialization.
Serialization. I was like, it's not sterilization. Okay.
Sterilization is actually a thing, but it's different than this. Yeah.
Okay.
Yeah. Oh, it's not sterilization, it's sanitation.
So, object distributes the format JSON, what's the format for deserialization?
Well, the format is, you take JSON as the format. The format is JSON, and then the output is an object. So there's no real format for the object. It's just you'll have an object in memory in the Java language. So like when we make a new object using the new operator, we'll create an object, right? Using JSON, we can reliably take that object and convert it to a string that can be read effectively by an end user. That end user can take that string, and instead of saying new object, they could say string.parse, string. And then based off of the value of that string, it'll make a new object. Okay? So like if you wanted to store information in a database, for instance, the database only contains text. You can't meaningfully store an object in Java as text unless you have a serialization format. Okay. So let's take a look at what JSON looks like. This is the JSON website. You'll note that there's a pattern with computer scientists. Is the better the computer scientists, the shittier their website.
Yeah, I've noticed that too. It's ironic, right?
It is, because they have basically, like, they give 0 Fs about design. They're like, I care nothing about that. I care about the science and theory behind this. So their website is purely utilitarian. It's like, I want to deliver you some data. Here is your data. Basically. And thus is an insight into the mindset of most computer scientists. So where the design aspect of this website is really bad, he does have this thing that he likes to call railroad syntax for describing what a valid JSON object looks like. So this is very similar to a grammar in most languages. It dictates what a valid object in JSON is. So you start out with, if you look at the left-hand side here, we have object. So JSON defines objects, right? So JSON objects will always start with an open curly bracket, right? And your option at this point is to go this path where you have a closed bracket, which is an empty JavaScript object, right? So it's open, like this is the most basic JSON is open bracket, closed bracket, defines nothing, right? Curly bracket. Ugh. Trying to bend my fingers back. Okay. All right, so if we decide to not go that path, but we go to the path where we define at least one thing, then it looks like this. We have a string, which is delineated by quotes, right? Remember, a string in Java, it's surrounded by quotes. It's called a string literal. It's the same thing in JSON. So after the string, there is a colon character. And then after the colon is a value. That value can be true, the keyword true. It can be false. It can be a number. It could also be a string. Okay?
Do you have to define it?
No, this is just data.
Okay.
No, this is just data. Now, this first railroad syntax doesn't actually take into account, by the way, so it says value. Okay, so here we go. This is where it gets interesting. So this box, so string is self-explanatory. It's anything that contains, it's inside of 2 quotes. On the other side of the colon, you can have a value, right? So he actually defines what a value can be here, right? So a value can be a string, or it can be a number, or it can be an object. Remember, the object was this guy up here, right? So you can have a JSON object be inside of another JSON object, which is very common, right? It could be an array, and in JSON object notation, that's a square bracket, right? It can be true or false or null, okay? And say a string is defined by the quote and then any like Unicode bullcrap that you don't really need to worry about and the end quote, right? So just keep in mind that's basically the same thing as before. So again, this is what it looks like inside of a computer scientist's mind, by the way.
It's neat. It's like a train.
Yeah, it's a formal specification for what this language is, what's valid for this language, right? So a number can be negative, and it also can not be negative. If it's 0, it can have a digit or not a digit, right? If it's 1 through 9, it can have a digit and any number of digits afterwards, and then a dot, and then any number of digits, and then that's it. And then also for scientific notation, you can have any number of digits, E, and then I guess E to the whatever power, and then E can be to any power, and then altogether that's how you describe a number at JSON, right?
What's the difference between lowercase e and capital E?
Well, to JSON, nothing.
Okay.
This proves to us that both E, lowercase, and capital E are accepted by JSON. So scientific notation is like, that stands for 1 times 10 to the E whatever.
Mm-hmm.
I think both are accepted.
It's like the same E that's on like a small calculator.
Yeah.
And that's why like you can take either path.
Yep.
Okay.
Yep. Cool.
Yeah.
All right. I haven't actually like stepped through with a class like this exact process, but now that I have, I think it's actually pretty enlightening. So these are the things that build up a valid JSON object. Now, and down here at the bottom, we have a bunch of libraries that help us work inside JSON.
So all of these can be converted to JSON.
All of the objects that we have in class can be converted to JSON, yes.
But all of these languages.
All of those languages are utilities which transmit objects, or they transfer objects from their native class or native object to strings. And the string is a JSON format. And they also contain methods that take in strings and convert them into objects. So that's what these libraries do. That's what this list of libraries
And that's what JSON does, or JSON.
JSON, yeah, is the language that data is written in, is one language that data can be written in. There are other languages that data can be written in. There's XML, it's another very popular language. You may have heard of XML before, like especially with the term AJAX, right?
Yeah.
That stands for asynchronous JavaScript and XML, which is ironic and misleading because XML is almost never used on the web. XML is pretty commonly used in Java though, and we will see examples of XML later in the class, but nowadays it's not really AJAX as much as it is AJAJ, which stands for asynchronous JavaScript and JSON, right?
Why would you use one over the other?
XML or JSON? It depends on the data you're describing. In general, I feel like JSON is a very natural way to describe data. So I think in very rare cases, would JSON be a worse choice than XML?
Okay.
But it depends on what you're trying to do with the data. So in some cases, XML is a fantastic way to illustrate the data, in which case you'd want to use XML. Now, HTML is a derivative of XML. So HTML is kind of like XML. It follows the same general patterns. And I would say that JSON would not make a good replacement for that. So if you wanted a real world example, HTML would be better than JSON at delivering this strictly hierarchical content.
Okay.
Yeah, XML is more human readable, like by default. Do you agree with that?
Again, I think it really depends on the data you're describing, because I've seen some pretty bad XML in my life that I don't ever want to see again. If you were to tell me, like, I've got your data in XML or I've got your data in JSON, the feeling I have of dread is significantly decreased if you say I have your data in JSON. Yeah. So, I mean, I could just take that as you will. Right?
If you were to like write some code in Java and then turn it into JSON and like try and put it into another language, what would happen?
That's totally valid. That's totally a valid use case. Yeah, that's one of the best ways to use JSON. It's a way to transmit data. So if I have an object representation in Java for like a person or whatever, and on the client there's a JavaScript representation of the data, then I can tell the client exactly what a person is by serializing it into JSON. And the client's like, oh, this is a serialized person object. I can deserialize it into JavaScript. And then here I go.
Can all of these languages be converted to each other's then?
Yeah, I mean, if you were working with a language and you use that language's JSON library to convert your object into a string, what you do with that string is entirely up to whoever consumes it.
Oh my God.
Right?
Wow.
Like if you if you have a URL, for instance, that all it does is deliver JSON, then people can consume that URL and do whatever they want with it. And check it out, that's called an API.
What's an API?
We're supposed to get into APIs on week 4, but an API is essentially a URL, like you know how you visit. I visited json.org to see this web page. There are other web pages that exist just to deliver data. So I could go to like Facebook has an Open Graph API. If you go to a special Facebook URL, it'll give you a JSON representation of a person, right? So if I'm writing an application, it doesn't matter if that application is an iOS application or an Android application or an application I wrote in like JavaScript or Java or any language, that data exists at that URL. So what I have to do is in my consuming class, in my consuming code, build an object that makes an HTTP request, right? So it makes a request to that web page. And then it's like, give me that data. And that data is the JSON object. And once I have that data, I can convert that data into an object that makes sense and reason about it in my own language.
Wow, that's awesome.
That is the heartbeat of all internets. Basically just describe the internet to you.
I had no idea you could do that.
Yeah, that's this is for future classes, guys. If we keep asking questions like this, we're not gonna have anything to talk about. I already have enough problems with Avery over here, like looking into like JSON serialization last week. So come on.
Well, I can't wait till my class on the seat.
I know, I'm really excited.
Yeah, that's actually the culmination. I'm happy that you guys are excited to head that direction, because the kind of end goal of this course is to learn about web programming in Java. So we'll learn all about that. But first we have to learn Java. Right. Good questions, guys. It's fun times. Good times. All right, so let's do a thing. That thing is convert some objects to and from JSON. So if we go back to our file.io lesson, we're going to do a thing that we haven't done yet, which is add a library to our code. IntelliJ makes this stupid straightforward. Again, we'll open up our file project structure or hit command semicolon. On the left here, we have a bunch of different options. We have libraries as one of the options. If we click the plus sign here, we can add a new Java or project library, in a location that we can add it from is either a Java class that exists on your machine or a Maven library. So Maven is a really great, it's called dependency management utility. So like Maven will say, in order to run my program, I need libraries X, Y, and Z, right? It's very popular. And so all of these libraries exist on a Maven server. And so like you can use Maven. So if my program relies on libraries X, Y, and Z, I can use Maven to automatically download X, Y, and Z onto my computer in the event that I need to run my program or compile my program, right? So you don't have to ever worry about, like, if you're using, if the math library, for instance, didn't exist in the Java language, if it existed, like someone just created the math class and they made it available for us to use, they would upload their math jar files. Remember the jar files we looked at before? They would upload them to the Maven repositories, okay? And then there's a string they can reference them by. So they'd give it a name. And then in our code, we'd be like, hey, Maven, I need the library referenced by this string. And so Maven would be like, that's cool, man. What we're going to do is we're going to go to that. We're going to query the repository for this string, find those jar files, and download them. And then if that jar file had other dependencies, it would automatically download those other dependencies as well. It's like a dependency tree. I'm sorry? On the left-hand side, like over here. I don't know if I can. Hold on. Hold on. Magnifying glass. What's that magnifying lens? Use a zoom window. No sex.
I don't know.
Toggle zoom.
You know how we were talking about food eating competitions yesterday? You know that in Japan, there's this one food eating competition where they have a sushi roll that extends from like a bowling lane, like where you get your ball, the bowling ball, all the way to pins. And these like tiny, tiny Japanese people like eat the whole sushi roll, and it's rice.
One person does like.
One person. Rice. And it's rice. It expands in your stomach.
Yeah, that's not a good idea. You'll explode.
It's a terrible.
I was thinking, because my stomach was so upset last night. I was just like, oh my god, I would throw up like all over the place.
Yeah, that's not a fantastic idea.
Like, yeah, that'd be painful.
Bowling lane, full of sushi.
And rice. Like,
There's
all
no-
the rice.
There's no, like, how many people consume this? A whole bowling lane full
Just one
of sushi.
person. One person.
We're not talking like, we're talking about bowling lane length, right?
Yeah, like the
Not like
whole
length.
thing, like,
Not and width, right? 'Cause
No.
that would be,
that would be insane. I think somebody would die if they did that.
You'd have to go directly to the hospital.
But even still, like the length is like incredibly long.
yeah, no, yeah, for sure. I mean, that's not something I would volunteer for. Speaking of weird, like things to do is, I have seen also cooking competitions in China that like the goal is to deliver as fresh of food as possible. So they take a fish, they basically cut it and they fry it right there on the pan, and the person who can deliver the fastest fish to the customer wins the competition. And the fish is still alive, essentially. I think you get no points if it's
Dead.
not moving. You get no points.
Wait, after it's fried?
I've never heard that.
Yeah, dude, they fry it alive.
But is it alive after it's fried?
I think it has muscle memory. Like, have you ever seen like a fish move around after it's dead? I think it's dead, but it still is moving because of
So
the.
it's moving when it's on the chicken.
Yeah. Like I've seen some like southern rednecks. They chop off a fish's head and then they just surprise and it's like, it's still alive. It's not alive. It's dead. It's very dead. But
It's like a chicken when you cut off a chicken's head.
I think actually chickens are different.
Really?
I think because I've heard of chickens surviving for like months on with no head.
Oh my god, ew.
Yeah, that might be.
That's like chicken head.
Yeah, that might be an old wives' tale. I'm not sure, but who knows?
I can't imagine that.
I don't know about months, but I think it's like hours.
Yeah, I heard that the only problem you have is that the throat can get like congested and they can suffocate.
So a chicken really doesn't need its head.
This is just hearsay. Honestly, I have no idea.
I think it just like takes longer to die.
That's crazy.
You'll have to talk to a chicken farmer who could probably has experience with headless chickens.
Really?
I mean, I think people underestimate how much of us is our backbone and even our stomach, right? Like our entire minds we think of as like the center of us, but we'll still kind of move if we don't have our head.
Right.
Whoa.
A lot of what we do is just our body's nerves are conditioned to do that. It's not all controlled by our brain.
Sure, when you chop off a head, like the person doesn't die of that, like they die of the suffocation.
I don't know. I'm pretty sure it'd be like massive hemorrhaging.
Yeah. But like I think like you first die of like suffocation, so it's like
Yeah.
it's like maybe 30 seconds or something.
Yeah. This is a fun talk and all, but we should probably get back to JSON. All right, so Joy, I did find this zoom method at NoSX. So it zooms into this window. Does that help you at all? Or okay. But I'm probably not gonna be able to stay like that. It's just so you can see it.
I just want to see what you're moving.
Okay, well, I'll try my best to zoom in when I interact with this left part here, okay? If you have, just speak up if it's just something you're not sure what I'm doing, okay? All right, so, all right, back to what we were doing. We were discussing Maven. Maven is a system for managing dependencies. We'll get more into Maven as we go along in the course. IntelliJ has its own methods for you to use Maven, one of which is through this libraries menu. The library that we're going to be looking at right now is this, it's called Jod. Jod is a pretty big Java library that does many things. The one we want to use is the Jod JSON library. So if we look at the naming of this, we can garner a few things from how it's named. First of which is that this organization is very similar to a package name in that it is reverse domained, right? So this specifies the domain this package lives under so that you can't ever have naming collisions like we have for, like this is the same process for package naming and class naming, right? And the name of this library in the org.jod domain is the Jod JSON name, and the version we want to get is 3.6.7, right? So that's the breakdown of this string. This string identifies this library and will give us a jar file when referenced by the Maven framework, okay? So we'll be like, bloop, copy, and then in our project, we're like, add a new library. The library we want to add is from Maven, and we want to paste it here. We click this little magnifying lens to search Maven for the library. There's no real good indicator that it found anything, except there's going to be the OK button is going to not be unclickable anymore. So once you click OK, then it's going to go ask Maven for everything. It's going to ask you which module you want to add this library to. So far, our projects have contained one module. So we're not going to worry about multiple modules for now. Just equate projects to modules, right? We're working on a project, we're working on one module. So we'll click OK. Boom. So we see we have these jar files here. We have Jod Bean, Jod Core, and Jod JSON. So all we wanted was Jod JSON, which means that Jod Core and Jod Bean were dependencies of Jod JSON, which it downloaded automatically since it couldn't do its job without those other two libraries, right? Okay, So once we have that loaded, we can see here that on this list over here where we had just the SDK, this external libraries window, we had just the 1.8 version of the SDK. Now we have 1.0 version of the SDK and the .json library. So in the same way that we could then import our types from the JSON or the Java runtime, we can now import the classes that were exposed by the library that this organization wrote. And those classes are designed specifically to interact with JSON. Make sense? See how that all ties together? All right. So once we have that listed and referenced, let's make a new class. Well, this class is read-write-file. Let's make a new read-write-JSON class. So in this class, what we're going to do is we're going to have a new person, P. Her name is going to be Alice Smith. Her age is going to be 30. So keep in mind, this is an object representation of a person. In memory, in the Java runtime, this is going to be a person, right? So by the way, if you wanted to save a JSON to disk, the format, the extension is .json, right? The extension is ultimately irrelevant, is only there for convention. You can name it .potato pancakes and it would be just fine. You could read in a potato pancakes file just like you would read in a JSON file. I don't even know if potato pancakes are a thing. It's just I happen to have two random foods in my head.
I love potato pancakes.
That's a thing?
Yeah.
Okay.
I was gonna say it's not kind of.
Oh, okay.
It's a Jewish thing, and they're really good with applesauce.
Oh yeah, latkes.
Yeah.
Latkes, yeah.
Potato
What's up?
I have a question. Why do we, I know this is going back, why do we do person P again? Why not just write person?
Okay, let's copy this text and paste it. We can experiment with what you mean here. Okay, so let's copy this text, this whole class. Oh god, that's not what I want to do. Sorry, I'm having some difficulty with the Zoom level here. Let's copy this. Okay, and let's make a new class here. Do read-write-JSON. Read-write-JSON. We'll paste this here. And we hit Alt-Enter, 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 Alt-Enter. Import new scanner. There is a way for you to import all classes for missing references, but I prefer just to go line by line because I don't know why. Okay, so Joy, your question was, so this line on line 13 here, we have person P equals new person, right? So your question is, why don't we have just person Q, for instance?
Or just person without the,
Just like this?
yeah.
Okay. So on line 14 at this point,
Oh, sorry, no, or just person equals new person. Or why not even just write their name? Like, why do we have to have person P?
Alternatively to person P, you would, like, you're asking, like, if I just type like Ben equals new person?
Yeah.
What you're asking?
Yeah.
Okay. Well, what we would be doing in this case is, what we'd be doing is trying to set something that's not a variable equal to a new object.
You string then with it?
That's closer, but no. So string Ben equals new person, that would be saying, hey Java, I have a variable. What I'm going to store in this variable is a string, and then immediately trying to store in that variable, which is supposed to be a string, a person.
Without any previous thing you just did. Or the,
This, on line 14 right now, that's exactly what it's trying to do. So we're like, so here, the variable initialization and declaration are two steps that we commonly have in one line. If we wanted to split them up, we'd do so like this. So line 13, that's how you make a new variable reference in Java. So how you make a new variable is you give it a variable type and you give it a variable name, right? So in this case, on line 13, we have the type is person, the name of the variable is P.
So we created a type.
We created the type earlier when we defined the class. We are now using that class in our code. Yep.
sorry, just one, I want you to continue, but one quick clarification. You said variable reference, is that the same as variable initiation? I mean.
Declaration.
initialization?
It's declaration.
Declaration.
Yes, ma'am. So initialization is when you assign that variable to an object
An equal or bracket, right?
with an equal sign. Yeah. Yep. The bracket is like array initialization syntax. Don't worry about that for now. The general concept is you assign a variable to an object value. Okay. So on line 15 here, if we want to assign P to a value, what we can do is say person P is equals to a new instance of a person class. And we create a person class, we don't have to pass it any values to the constructor. So that'll give us a new person, right?
Because person brackets is the constructor.
Yeah.
So then
If we look at person, it doesn't have a defined constructor. Well, it does actually. The constructor that we're currently using has no parameters, right? If we didn't have any constructors, the same constructor would exist. Except it wouldn't say, I made a person object. It would say nothing, right? So people did this series of things so frequently as a part of the language design, they asked themselves, why don't we give them the ability to declare and initialize their variables in one line? Because it added a lot of code bloat there. Like, this doesn't make any sense. Why are we doing it? So we can take this and reduce it down to that. So on one line, we have person P, that's the declaration, equals new person, that's the initialization. So it's initialized to that value and declared. Or in order, it would be declared and then initialized to that value.
So you've already declared P as the new person, so now you can add like fields to P.
Hypothetically speaking, if you are using the person class in your consuming code, then you would already have defined those fields. But you can add fields to person after you use the person class in your code somewhere. It's
Okay,
just you have to update your code accordingly.
you can assign values to that person's fields.
Yeah, no, yeah, exactly. So like that's what we're doing here on lines 15 and 16 is we're setting the field values name and age to their associated.
But you're not
Arbitrary class.
limited, so if you want to create person Q, you could do that as well and call him Johnson.
Now another question is, what if I did this? Oh no, did it finally break?
No. Oh no.
It's been doing a great job. No, it seems to be, my screen is updating and I can see it update. So it must be Apple TV. Hold on. Okay, there's a slight hiccup with Apple TV. No big deal. All right, just ignore that. So what if I said, nah, dude, that's gonna mess up everything.
Person Q equals person P, or equals P.
Person Q equals P.
Then wouldn't you be creating like, ooh, a new Alice Smith, like another Alice Smith? No?
Just two ways to access Alice.
Exactly.
Oh.
He comes from a world where this is a very common thing.
Why'd
But
you want that?
if you wanted to pass a variable into a method but not pass all the contents of that method in there, it would be like this. In fact, that's how Java does that under the covers. That's not very clear. You have to have more of a context, I think, to understand completely why. But you can have multiple variables reference the same object in memory.
So when it says P name Alice, is that only, we're declaring it as only Alice Smith? Or will we be able to define name again, P name as Ben also?
We can't have both values exist in names simultaneously, but we can set that name as many times as we want, right? So if I said p.name equals Alice Smith, then we said Joy Meekins. After line 16 executes, P's name field would contain Alice Smith.
Let's see.
Immediately afterwards, it would execute line 17, which would reassign the name field to Joy Meekins.
So then we have to do Q if we want to assign new names, so we have to do P2 like we did later on.
No, we don't have to. The queue is not necessary in any means. It was a thought exercise that I was presenting to Lizzie.
Let's say that like we're setting up a database for like the government or something, and it keeps all of your records. So it has your name, your social security, your address, all of like that kind of stuff.
Mhm.
So let's say Alice Smith changes her name to Joy Meekins, but we've already created our database, right? So we want to change all of any instance of Alice to Joy. But we can't go back to line 17, can we? Or line 17.
No. When you get into database transactions, this becomes a little bit more complicated. It's not as straightforward as set a field value in an object, right?
So then, sorry, one quick follow-up. So then, how do you define a new one? If you don't want it to run back to Alice, I mean, if you don't want it to be Alice to be replaced with Joy, how do you set a new person?
If you wanted both Alice and Joy to exist at the same time, you would need to either store them in an array or just create another person variable, right? So you could have person.
Person is a class, right? So you can have many instances of that class.
Exactly. As much as your computer will allow you to do, which is a lot. So if we want a person Joy to exist, Joy's.name is equal to Joy Meekins. Joy's.age is equal to 20-something.
So you just have to, okay.
Say, yeah, this is arbitrary, like let's say 25.
Sure, let's go with that.
Yeah.
I'll take 25.
Yeah? Nice. Okay. So after line 19 executes, we have two people in memory. We have Alice and we have Joy. Okay? We have two local variables. We have Alice and Joy, right? That point to those objects in memory. The field values for each are Alice's name is Alice Smith. Alice's age is 30. Okay? So Alice and Joy have copies of both fields. They have copies of name, they have copies of age. So they can set them independently. So if I change Joy's name, it doesn't affect Alice at all. However, if person did have a static field, like number of heads, static number of heads, static int number of heads, then I was like person dot number of heads equals 1, and then person dot number of heads equals 2. And after line 21 executes, person dot number of heads is going to be 2, and that's applicable to every, like if you were to reference that field in any person object, it'd be the same value.
And that's because I set it as static.
Mm-hmm. And the person, yeah, exactly.
Unless you use an override on a different person, then they can have whatever number of heads they want.
When it comes to static fields and static methods, you can't really do any overrides. No, I mean, overrides are really restricted to instance methods.
If I wanted to change, sorry, everybody. If you wanted to change, make Alice have 1 head and Joy have 2 heads and leave it without it resetting to like being static.
Yeah.
What would you do?
What do you think you would do?
You would type Alice dot number of heads equals 1,
Correct?
and
As,
then Joy dot number of heads equals 2.
yep, but since this isn't throwing a syntax error because Java is forgiving when it comes to stuff like this, but technically that's not the only thing. So basically by saying that, what you're saying is you want number of heads to behave exactly the same way that name has and age is, right? Like, so those behave in a way that you can set those independently of one another, right? So if we look at how those are declared in the person class, we'll see that it's type and then type name, or a variable name, field name. You have type and then field name, type and then field name. And we have static type field name here. So we can't just reference it by the object's dot number of heads way. We also, if we want it to vary per person, remove the static keyword. So now at this point we have an int. Each person has their own number of heads, which is pretty similar to real life.
Okay.
Good? All right. Okay, so if we go to the task at hand, which is reading and writing JSON, let's go ahead and remove this stuff here. So say we want to store Alice Smith in a file called person.json. So we have different things we're doing here. We can write JSON, and what we're going to be doing here is we're going to be serializing JSON. The JOD library has a class called the JSON serializer. If we go to the definition, we can see that it came from a package jod.json. We're going to name this variable serializer, and it's going to be a new instance of serializer, right? Just like we declare any type in our code. So we're going to use the serializer on line 20 to serialize this Alice object, okay? And then that's going to give us a string that is the JSON contents of that object, or that object as JSON, represented as JSON. And then, just like before, we're going to use a file writer object to write this string to the file, and then we're going to close our file writer. And if we wanted to read JSON, we do it just like we did before, except we add a step where we use the JOD library to parse our contents. So we have a scanner. So it's new scanner F. F is the JSON file name. We call use delimiter, which again, this says the next token give me everything between where we currently are and the end of the file, which is the entire contents of the file. We're going to say the string contents is equal to the next token, which again will give us the entire contents of the file. And then we're going to make a new JSON parser variable. JSON parser. Parsing and deserializing are kind of synonymous. In order to deserialize something, you have to parse it, right? Part of the compilation process is parsing the text that you read in from the file, okay? Part of deserializing is parsing the JSON and then converting it into an object. So we have a new JSON parser. So we make person P2, it's a person object, is equal to a parser.parse. And we're going to give it a string. We're going to give it a class reference. So we haven't looked at this yet, but the way that you can identify a type, like we have objects of that type, but the way you can pass in, like, I want this class, essentially, is to get the .class reference. This is inherent to the Java language. So you can type in type name .class to get the reference to a type. So what this says is I want to parse this string as JSON, and what I want it to return is this class. So we type in person.class, right? And the end result is that we get person P2 initialized to that value. So, like before, we have to add a new run configuration for the read-write-JSON class instead of the read-write-file class. So we'll just click that and add our new run configuration and run it immediately. So, wow. Apparently I added a valid identifier here. So if age is not 0 or age, oh, is alive is false by default. So let's just go ahead and just, you know, it's interesting. This is a funny thing. So the JOD library, when it deserialized our types, our string, or sorry, when it deserialized that string into a type, it tried to look inside that type for methods that follow the getter and setter paradigm. So you see, we haven't seen this person is invalid error up until now because we have been just using the field access. But the JSON parser library used the set age field here to set the age of this person. Okay, and since by default they don't have an age, like since the default age is gonna, or no, sorry. By default, the is done field is going to be, or is alive field is going to be false. So if you make a new person and you don't specify is alive, its default value is false. So our setter is saying like it's not valid. So age is 0, and age is not valid because they're dead, right? So it says person isn't valid. So the JSON parser library is using this setter because it followed that convention, right?
Mm-hmm.
So a lot of Java frameworks, like they check for the presence of these getters and setters to do their job because they prefer to use them over just direct field reference.
So then we can change that by setting the age, right?
After we read it into the object?
Yeah. Or
Yeah, after we read it into the person P2, we're free to do whatever we want with it.
so they wouldn't be alive.
No, I know very few people who are 23 million years old.
No, I mean, but like according to the computer, they wouldn't, because they wouldn't meet the or statement.
Yeah, but we didn't use the setter.
Oh.
So this is why you should make your fields private when you can. And when you use getters and setters, you should probably make your fields private, because I was able just to see this and change it, right? So if I wanted to do this instead, I think I want to make these guys private and restrict their access and the getters and setters to just getters and setters, then I wouldn't be able to set name and age. I'd have to go through p2's.setAge method. And this, like you said appropriately, would kick me back and say it's not a valid age. Thus, the reasoning behind getters and setters. And the reasoning behind object-oriented programming. Because without using those access modifiers, as the consumer, I would be able to directly touch age and name without any restraint or restriction.
And that probably plays a big role in like security too.
It really is not so much security as it is guiding people into how to use your code. So when you write code, almost a lot of the time, it's for someone else to consume. And you want to make it as evident as possible to what your code does and the things it can do, right?
Is that a problem, like if hackers come into your system though?
Not necessarily, no. I'm sorry. But what you're describing is a pretty common thought, but it's not a good security practice. Making your fields private does not protect you from intrusion.
Okay.
Making your fields private is an architectural decision that like just allows you to indicate the purpose of these variables and fields.
Because if they're in your code, they can see that anyway.
Yeah, I mean, like whatever you can accomplish in your application, the hacker can accomplish, period.
Yeah.
So
Okay.
whether or not your application makes things public or private, it doesn't really matter. If you have a goal that you're accomplishing in your code, the hacker can do the same thing.
Right, right.
If they find a way to inject their code onto your server somehow.
Will we learn security like that?
We're going to go over when we get over, we're going to do like web-based stuff, like web security stuff. We're going to go over like certificates and HTTPS and SQL injection vulnerabilities and cross-site scripting and phishing attacks, stuff like that. What's up?
Are you sure that this video is going to be accessible after you stop it?
I am about 80% sure.
And we just need to click that link again and see the history?
Yes. I tested it out last night and yesterday, and the audio didn't work, but I confirmed the audio was working in the Hangouts earlier, so it should be okay now. I'm a little concerned that that hang up earlier may have interrupted things, but if so, I'll try to account for that, accommodate for that. Okay, so ignoring this line, what we're going to do here is we're going to take this object we created, and I'm going to actually undo this change I made to these private variables because it just makes my life inconvenient right now. We're going to make a new person object. We're going to set that person's object's field values. We're going to serialize that object to a string. we're going to save that string to a file, and then we're going to close our file writer, and then subsequently we're going to take the contents of that file, read it in, and print out what they are. So let's run it. Read write JSON, go. So you can see here it does the same thing as before. That's fine. If we take a look at person.json, let's remove our setter because it's screwing up everything for us. Person. Let's remove the restrictions on age and name. Oh, there's no getter and setter for name, so that's why it's failing. Let's remove this get set age and name thing. Now let's get rid of all this shit. Everything, getting rid of it all. We're going to use our code generation utility to make getters and setters for every valid field and rerun our code. Good. Person.json. Good. Okay. So since we added getters and setters for all of our fields, this is the JSON that was output by the library. So the age is 30, alive is false, name is Alice Smith, the number of heads is 0.
It's so simplified. I love that.
Yep. If you think in your mind back to that railroad parser engine, you can see how it defines this text. Yep.
Beautiful.
Yeah. I think that's a good way to put it. Beautiful. All right. The one thing I'm concerned about is that at the end of this read write JSON class, it didn't print out anything. Oh yeah, it did. Here it is. So this hash value. So check this out. We talked about the toString method. Okay. It exists on objects. By default, the object toString method is just that @ with that hash and the class name, right? Just like this, right? It's a class name, @ and then a hash, all right? So we learned about something very similar, or something very recently we learned about, where we can change the default behavior of toString if we're working inside of a subclass. So the superclass in this case is object. It contains a toString method. We talked about earlier today a way to override toString or override a given method to perform the way we want it to perform. So if we want to be able to print out a person that doesn't look like this when we call toString on it. So by default, if you call print line on this object, it's going to call toString on that object. So that's why we're seeing the results of this. So if we were not satisfied with the outputs when we print line a person object, we could update the person's toString method to override what we get from object. And lo and behold, the code generation utility from IntelliJ allows you to override toString. You specify which fields you want to be printed when you toString an object. You hit enter, and it gives you this pre-specified formatter that just says person is that. If you run it again, it's going to read and write this file, and the object that it outputs is something very similar to JSON, but not exactly the same, and it just gives you a much more friendly to read string that represents your object. So we've meandered a lot today. We haven't, precisely stayed on exactly what tasks we wanted. However, it's not bad. I think it's all good. If you are concerned or you want some reiteration of the concepts we learned today, I would encourage you to open up the Text Adventure Game project and follow along the steps that are outlined in this lesson. However, I think that in terms of lecture, we've covered enough topics for one day. We've definitely gone across the board in terms of things. So that's it for today in terms of lecture. Do you have any questions? Nope. Well, great job today, guys. I really love the questions we had today. If you want to gain clarity to anything, just let me know. And I encourage you to take a crack at this text adventure game. I think you'll gain some valuable insights into that. Just let me know if there's any problems with that, okay? All right. Let's get some lunch. All right.
Are there any grocery stores around here?
I think so.
Like close and walking?
Let's find out. Goodbye, my adoring fans, all 0 viewers. Have a nice day.